Where do forces come from? All forces arise from the interaction of two objects with each other. In this example, we have two objects, 1 and 2, interacting with each other, in this case because their surfaces are in contact with each other, one sitting on top of the other. And the interaction between the two objects gives rise to a pair of forces. I have one force that's acting from object 2 down on object 1, and the other force that's acting from object 1 back up onto object 2. And these forces, following Newton's third law, are equal in magnitude and opposite in direction. What if we now push these blocks horizontally in opposite directions? At their interface, there is a frictional interaction. This interaction gives rise to a pair of frictional forces that are parallel to the interface. The friction force on the top block from the bottom block is opposite in direction but equal in magnitude to the friction from the bottom block due to the top block. Let's look at some of the common misconceptions about forces. First of all, motion is not a force. If I have a block that's moving at a constant velocity along a frictionless plane, then there's no horizontal force that's acting on this block because there is no interaction that would give rise to a horizontal force. The fact that it has a velocity does not necessarily mean that there is a force acting on it. Another common mistake is to think that forces transfer through objects. For example, if I'm pushing a book against a wall, it might seem like the force from my hand is being transferred to the wall. But what is really happening is that there are two independent interactions. The interaction of my hand with the book and the interaction of the book with the wall. And these are separate interactions. The forces might happen to have the same magnitude in some cases, but it's not because the force from my hand is being transferred. Forces arise between pairs of objects, and those forces can only act on those two objects. Let's look more closely at Newton's third law. So Newton's third law says that when there are two objects that are interacting, there will be two forces that arise from that interaction. And these two forces are always equal in magnitude and opposite in direction. These two forces, this Newton's third law pair of forces, never act on the same object, but instead one force acts on the first object and one on the second. Because these forces arise out of the same interaction, they have to be the same type of force. So they could be gravitational forces, frictional forces, normal forces, etc. Let's look at an example of a book sitting on a table. It's being pulled down by the gravitational force, and it's being held up by the normal force. Are these two forces a Newton's third law pair? The book is not accelerating, so these forces are equal in magnitude and opposite in direction, but they cannot be a Newton's third law pair for two different reasons. First of all, they both act on the same object, the book. And second of all, they arise from different interactions. The normal force on the book is part of a Newton's third law pair that comes from the interaction between the book and the table. What's the Newton's third law pair of the gravitational force on the book? Well, because the gravitational force arises from the interaction between the book and the earth, the other force in the Newton's third law pair is actually the force that the book exerts on the earth. You might not think about the book acting on the earth, but the force is actually equal and opposite to the earth's force on the book. It's just that the earth is so much more massive. The force has no detectable influence on the earth's behavior at all.